All right, so taking a look at Algebra, Lesson 5.3. So how do we think of slope? I've talked about this a lot of times. What is slope? How would you describe it to some third or fourth grader? Well, we always talk about it as the steepness, how steep a line is. So now remember, if it goes up to the left, we say the slope is negative. If it's going up to the right, the slope is positive. So slope is simply the steepness. So here, the slope between these points, is it going to be positive or negative? Well, let's see. It seems to be going up to the what? Up to the right. So we're going to say, hey, that's a positive slope. How do we calculate the slope? Well, remember, we're simply talking how steep it is. And what we use is we talk how it rises over how much it runs. So this seems to go up 1 unit and then over what? 1, 2, 3, 4, 5 units. So we'd say, hey, that has a slope of 1/5. That describes how steep it is, 1/5. And we do say it's positive 1/5 because it's going up to the right. It gives them a direction. Well, what about this? Let's take a look at this guy. Well, first, as we say, is this a positive or negative slope? Well, it's going up to the what? Left. So we're going to say, hey, that's a negative slope. That tells them the direction. Now, to figure out how steep it is, well, let's count how much it goes up. 1, 2, 3, 4, 5, 6. And then it goes over 1, 2, 3 units. Rises 6, runs 3. We would say, hey, that's a slope of 2. We simplify it. Now, do we say a slope of 2? No, we say a slope of what? -2 to tell them the direction that it's going up to the left. But notice how much steeper that line is than that line. This line was not that steep, was it? See, it tells us how steep a line is. Now, here's a little saying I have. Let's say there's a fire. If there's a fire, you're going to rise with the wise people and run to the exit. Those that aren't wise are going to sit up there and sit in the classroom and burn up, and we don't want that. So what's the point of this? Rise with the wise and run to the exit. We're playing off of the word wise with a Y and playing off the word exit with an X. Now, why are we doing that? Well, notice this helps me with slope. Rise over run, which rising is basically how much you're going up, which is the change in your Y's over the change in your X's. And that's what we have right here. We're saying, hey, slope is rise over run, which is basically the change in your Y values. This right here, delta symbol, means the change in your Y values divided by the change in your X's. Now, why do we need that? We need that because we're not always going to have a picture. Sometimes it's going to say, hey, what is the slope between these points? Well, I can't draw a picture. I could, but boy, that's going to be difficult to do. So we try to remember slope, rise with the Y's. So the slope, which we know is the letter M, stands for slope. We've learned that before. Rise with the Y's, run to the exit. So what I'm going to do is I want to just simply subtract my Y values divided by subtracting my X's, because the subtraction of Y's is going to tell you how much you went up. And then subtract your X's will tell you how much you went over. And that's what we do, rise over run. So we need to subtract our Y's. Now, does the order matter? No. You can do 66 minus 166 or vice versa. You can do 166 minus the 66. That's what I'm going to do. I'm going to do 166 minus 66. Divided by, now I need to subtract my X's. Does the order matter here? Yes. Because you went from 166, you went from this point to that point, you were subtracting that direction, you must start with 28 minus the 24. You cannot switch. If you switch it, you're going to get the wrong direction. So since we started with this 166, when we do the X's, we have to start with that X. A lot of people say, oh, Y sub 1 minus Y sub 2 over X sub 1 minus X sub 2. That's all it's referring to. It's just saying, hey, wherever you start, if you start with this Y, you have to start with that X when you do the subtraction. So here, what do we get? 100 over 4. It's a slope of 25. That's pretty daggone steep. You could not walk up that at all. That would be impossible. We also know it goes up to the right. So if I did graph the 2466 and the point 28, 166, it would be going up to the right. Let's look at another one. Slope between these points. I could graph these, but I don't have a graph, and it's just easier to say, hey, the slope, rise with the y's, run to the exit. Subtract my y's over subtract my x's. And again, I'm going to do 14 minus 6. And since I start with a 14, I must start with a 2 and do 2 minus the 4. This is going to give us 8 on top, negative 2 on the bottom. This means it has a slope of negative 4. The negative is just indicating that this is going up to the left. So if we plotted these, we know, and I didn't even pay attention what the points are, we know it's going up to the left. And it's going to have a steepness of 4. It'll go up 4 over 1, up 4 over 1. Okay? That's what we know. One more example, okay? Because we have to be able to find the slope between points. We do this all the time in math. Rise with the y's, run to the exit. Let's start this time. I'm going to start here this time. So I'm going to do negative 6 minus negative 2. And since I started with that y value, I must start with this x value. Negative 2 minus, what's that x there? Negative 4. All right, let's work it out. This is going to be a plus. This minus the negative down here will be plus. We'll get negative 4 over positive 2, which gives us a slope of negative 2. So we know that line's going up to the left. And it has a steepness of up 2 over 1, up 2 over 1. That's how we find the slope between points.